Hi everyone, this is Russ from Sparx Hockey. We're here today for another episode of The Edge. This is part 2 of our series where we go back and we look at some of the earliest prototypes that led to the Sparx Sharpener. And in our last video, we showed you the first prototype complete sharpener that we built. In that sharpener, we attempted to manually dress a grinding wheel and had an external mounted skate that moved across a stationary grinding wheel. We called that the exoskeleton design because it resembled what we were fans of, which was like mountain bikes and things like that, where you could see the structure of the product. And so what we learned from that experience was two major things. One is having all of that externally accessible parts like a skate made it very easy for a human, someone that's actually interacting with the skate sharpener, to disturb the sharpening process. And the second thing we learned was, and this is a great lesson for any entrepreneurs out there building a hardware product, it's best to separate the design, the aesthetic of the product from the physical function of the product. And we were sort of doing both at the same time. We were trying to design a product that looked good and functioned at the exact same time. And we kept tripping over some of the very fundamental mechanical, physical problems at the same time that we were like dragging along this physical aesthetic design, and that just wasn't the way to do it. And so in iteration 2, in the second prototype, what we have here is basically an erector set. So this allowed us to have as variables the diameter of the grinding wheel, whether or not the grinding wheel was a vitrified bonded traditional wheel or a more modern super abrasive wheel. We could play with motor selection. We could adjust the length of the motor arm, the pivot arm. We could change the amount of force, the normal force going up between the skate and the grinding wheel. And this erector set design was totally the way to go. We didn't know it at first, but once we got to here, we could very quickly iterate. And we'll show up on the screen now, we'll show all of the different geometries that we went through to arrive at the final geometry of the Sparx Sharpener. And this was it was both a CAD and calculation-based iterative loop, as well as an empirical model-based iterative loop, where we would figure out what geometry we wanted to test, then we would build and test, and just keep going, basically fail till we eventually succeeded. This probably took over a year of iteration, and not only were we changing the physical parts in the mechanisms that were used to sharpen the skate, even things like how are we translating this carriage back and forth. This is the early prototype of the carriage that moves back and forth in the Sparx Sharpener. Do we use a belt? Do we use a rack and a gear and push it along? And so that was some of the iteration that was happening here as well. We weren't messing at all with dust collection. We weren't messing at all with user interface and how the user was going to actually interact with the product. We were 100% focused on skate sharpening performance here. Again, you'll see this was in the last video. This was the controller that we used for the previous prototype. We just carried this along because all we were doing now was just, again, translating a motor that was sharpening a skate. We had a very, very primitive clamp here holding onto the skate blade. So once we had, again, we're simplifying it to say, once we had the final configuration, because this took a really, really long time to figure out, then what we needed to do was translate this into the cosmetic design, as well as to convert this Arduino-based controller into a custom circuit board that was designed for mass production that could control Sparx. And so we went to 2 prototypes from this point forward. We went to this, what we call the Mule. This was Gamma, and this is the Mule. And this was used by our software engineers and electrical engineers, where it just had the electrical inputs for the Sparx Sharpener. So there was really no skate blade necessary. All it had was a motor to translate the carriage, and in this version, it's a rack and a pinion. It had the grinding motor, and it had a bunch of switches that represent, a future door, scoops, which are the safety covers on the sharpener, the tray position, filter position, all these things, and the electrical engineers and software engineers could work with this to design the state machine and the circuit board that would eventually go into this, which was the physical prototype. So this is the mechanism, and we had to convert this into a physical prototype. And this was the first Sparx sharpener we ever built. You can kind of see, for those familiar with Sparx, originally we had the control board up on a little satellite component up on the top of the machine. And there's controls on here that don't even exist anymore, and indicator lights such as this one to let you know that the door is open. And the scoops were very, very different in their design. They had levers to actuate the locks to put them into place so they would lock into place. They had the scoop doors. They had a handle that was not removable because we hadn't yet figured out that we needed a removable handle to fit into our travel case and to make the handle less likely to be broken off. Really quickly, some of the other interesting features here for people that are into prototyping and prototyping technology. This was an SLA tray for the Sparx sharpener, and we actually, at the time, SLA didn't exist large enough to build the entire tray in one build, and so we had to actually build two and glue them together. And then what we see in this product is many different rapid prototypes or 3D printed parts, such as these right here, but some of these really, really large parts, we actually cast them in urethane and then spray painted them black. And none of this, there's no extrusions in here, there's no castings, it's all 3D printings and castings, plastic castings that are then spray painted. And so there's a lot of shortcuts taken to make a physical prototype like this. But what it allowed us to do is take the physical hardware that worked and now see if we could package it into something that looked great and still worked the same. With that, I'll ask the team if there's any questions.
Yeah, of course I have a question. So you were saying how you were separating purposely the design from the function. How did you seem to know though that there was going to be a door, that there were going to be safety scoops, that so was there some simultaneous conversation happening around that stuff, even though you were hyper focused on the mechanics?
Yeah, so while we were here, we knew we were going to need to protect this stuff because the original design showed us that we can't allow hands to get near anything that's moving because the most subtle movements of this machine will throw off the sharpening. It'll create a chatter mark. And for anyone that has a Sparx machine or any sharpener, you realize how sensitive that machine is to putting a nice, even mirror-like finish on the bottom of the skate. So we knew we needed to isolate all the mechanical components. So we knew there was going to be some sort of an access door. We knew from products that existed on the market that had a configuration similar to the direction we were going, that had very large portions that could still, even with the doors closed, that could still be accessed by fingers. And so we knew we wanted to have scoops, and we wanted to really pioneer the safest sharpener in the world. We wanted to have a sharpener that you could not touch anything, and we would use software that if any access point were open, the sharpener would turn off. Again, because we were going after the everyday consumer. We wanted this to be in every hockey player's basement or garage.
And then just sort of a follow-on is, now that you knew the mechanics, you knew what switches essentially you wanted, you had to get from those two erector sets to that sort of sleeker looking design. How did that process go? Who was working on that?
So the 3 or 4 of us in R&D, and then we had outside industrial design help, even though we were very far along on this concept in its look. But what the industrial designer helped us do from the outside, it's amazing working with art type people. They did little things that if you notice on the Sparx sharpener, these walls are not, actually in this version, they're already pitched over, but things like pushing these walls in from straight, just subtle things like that, taking this and removing this. Things like putting this front face on a slant, like breaking up that boxy look that was common for every other sharpener that existed in the world, needed the help of somebody outside that had that eye. Another sort of interesting development was this window wasn't on there in the beginning, and we had a door that was not transparent, and But in the beginning, when we were figuring out some of the geometry and we actually wanted to watch the sharpening happening so that we could actually see what was going on in our own products, our industrial designer was here and we were talking about the design, and he saw one of our prototypes that had a window, like a plexiglass window on the front of it. And he's like, I love what you did. And we're like, what do you mean? And he's like, I love the window. And we're like, what are you talking about? It's just here for engineering purposes. He's like, nope, it's going to have a window. That makes it. That's the way we're going to go. And from there is where we develop the lighting and the indicators, where we have the green lights to let you know that the sharpening is done, and the red lights to let you know if there's a fault. So all that came about almost by mistake. Excellent. Well, thanks everyone for tuning in for another episode. In the next episode, we're going to talk about how we went from here to showing it to tens of thousands of people in Kickstarter, and then from there into mass production. So thanks again for tuning in. We'll talk to you next time.